Hi again. This is section 6.6, the standard normal Z. So Z is normally distributed with a mean of 0 and standard deviation of 1. We are going to find some probabilities using our calculator. These are the exact same probabilities that I did in the previous video using the table, and I wanted to show you how to do the same thing on your calculator. Realistically, most of the students used their calculator for all of these because it was much more flexible in using different means and standard deviations. So, how to do this on your calculator. The first one says find the probability that Z is less than 6.8 or 2.62, right there, 2.62. So if we look at our picture, here's my Z curve. So this is, we want the probability that Z is less than 2.62. Z less than 2.62. I'm just including the picture to give you a sense of what you're doing, this area. Including everything down to infinity, less than 2.62. So we're going to do this on our calculator, but I wanted you to see the yellow area so you could visualize what your calculator is doing. So we want to know, what is this area? I'm guessing it's bigger than 0.5. So here are the steps you use for your calculator. Step 1, turn your calculator on. You did that? Fine. Okay, so for these probabilities, especially the one-sided ones, for the calculator you want to always think of a lower bound and an upper bound. So I actually write in the margin with my pencil, when it says Z less than 2.62, I change the problem so it says negative infinity, Z, and then 2.62. And you can see that in the picture. We want Z from negative infinity, this is kind of a strange concept, negative infinity, all the way up to 2.62. We do that because we have to type these numbers into the calculator. So turn on your calculator, go to second function. For me, it's a yellow button. For some of you, it's a blue button. And go to VARS, VARS. I think that stands for variables. So hit second function variables, so you're actually hitting distribution because you want a normal distribution. Arrow down, use your arrow keys, and it's the second one. It says normal CDF. We're going to use the CDF. It's the cumulative distribution function because we want all the area. So, but just think 2, normal CDF. And now we're going to type in the sort of process here. The little formula you always use is lower bound, upper bound, mean, standard deviation. So the lower bound is negative infinity. We can't type negative infinity into the calculator. It will explode. You know, you just won't know what to do. So we type in -1. Make sure you can find the negative button. It's over at the bottom. The bottom right, -1 times 10 raised to the 99. That's the negative infinity, comma, 2.62, comma, 0, comma, 1, and hit enter. So what you're doing, you arrow down here. When you come to typing, you hit -1 times 10 raised, this little raised to the button, 99, comma, 2.62, comma, 0, comma, 1. Close the parentheses, just a regular one, don't do a bracket. Hit enter, and your calculator gives you 0.9956. Okay? So we say fine. We know this area here is equal to 0.9956. Great, love it. Next problem. Find the probability that Z is greater than 2.62. So some of you can see on the picture that the greater than part is going to be 1 minus the less than side, 9956. We did it with the tables. But we can do it on the calculator. Let's do it on the calculator. Why not? In case you don't want to think that much on a test. So Z greater than 2.62. Again, you want to think about the two boundaries when you're using your calculator. So it's 2.62. Z is between 2.62 and positive infinity. So it's everything from here up to positive infinity. And you could have less than. I just put less than or equal to. Sometimes I go back and forth. It doesn't really matter because it's the area of a line. So don't worry about this not being less than or equal to. So here's what you do. I write this in the margins of my paper, 2.62 and infinity. So you type second function variables. So again, you're going to distribution. Second function variables. Then you arrow over or down to normal CDF. Hit enter. Now we're typing in the lower bound, which is 2.62, upper bound, which is 10 raised to the 99. That's positive, so we don't need to say 1 times it. The mean, which is 0, and the standard deviation, which is 1. Close the parentheses here, and then hit enter, and your calculator gives you this. 0.0044, essentially. So that little area there is 0.004. The calculator says 39. The rounding errors are unimportant to me on a test. I'll tell you how many places I want you to round out, but it's, you know, I'm not going to mark you wrong if you write 0.0039 or 0.0044. Either way is fine. The next problem, a boundary. This one's easier actually on the calculator. Harder on the table, easier on the calculator. Find the probability that z is between minus 2.62 and 2.62. I just typed in the answer. Oh no, I gave it away. So in this case, we want, here's our minus 2.62, we want everything in between here. I'm going to change colors, make it orange. So we want it between here, there, that area. Maybe I'll make it blue. That area, there, that's better. That's the area we want. So on the calculator, we already have a lower bound and an upper bound, so this one's easier in a way. Type second function variables, yep. Arrow down to normal CDF, type in the lower bound minus, make sure you put the minus in there, 2.62, comma, upper bound 2.62, comma, 0, that's the mean, comma, 1, standard deviation. Hit enter. Your calculator gives you 0.9912. So once you get in the roll of this, it's pretty straightforward. And again, you go to a picture, you're saying that area is 0.99. Did I say 72? 12? Something with a 2? 12! Oh well, make that a 1. This is what I deal with when I'm grading tests. You guys do this. 1. It's a 1. It's really a 1. So now the most important thing, you're going to want to pay attention. Chop chop, pay attention. It was me waking you up in a video. This one. Find the 60th percentile of Z. Okay, again, that's the answer. Find the 60th percentile. So you can do this on your calculator and it's really nifty. Let me draw you a new picture. This part is cool, you guys. We are looking for the 60th percentile. So there's some number, so this right here, make a line. This is the mean. Alright, that's 0. Ooh, well, I'm excited I got it kind of straight, but then I messed it up. So we want some number that is 60, the area is 60%. Some number such that, and I'll just draw a little line here like this. There's some number here, and we don't know what it is, but we do know that the area behind that number, that part is equal to 0.60. Did I say 60%? Yes, 60th percentile. 0.60. So we want, what is the number? So we're going to call this number y. What is y? Such that the probability that z is less than that equals 0.60. And that comes from our definition of percentiles. It's the numbers such that 60% are equal to that number or less than or equal to that number. So what is this number? So with the tables, you had to look inside the probability, but with the calculator, it's really slick. So watch this, you guys. Turn on your calculator. Second function distribution. So second function variables right here. And you arrow down to the third one now. Go to the third one, which is invert normal. So in this case, invert normal means we're given the probability and you want to find the number. Okay, so hit enter there. Now it's waiting for you. You're going to type in the probability, your percentile. So in this case, type in 0.60, comma, mean, standard deviation, in parentheses, and hit enter. And 0.6, comma, I'm doing this live, 0, comma, 1, end parentheses. It's so fast. And it gives you, what did I say? It gives you 2533. So if we go to our picture, we're saying this number here equals 0.2533, When we did it on the tables, we said it was between 0.25 and, that's an and, 0.26. So we are correct. It's a little bit closer to 0.25, but it's okay. We can sleep well at night. It's close enough. So the answer is 0.2533. So we say 0.2533, and that's a number on the number line, is the 60th percentile for Z. And that's how you do it. Percentile. Except you can't write percentile for Z. Z standard normal. So again, the key here, what I really wanted to take you through, was this invert normal function. You type in your probability, mean, standard deviation, enter. Bam! So much easier than the tables and the other way to do it. So using this inverse function is going to save you a lot of time, and you will be sad if your calculator doesn't have that function. Okay.